Good afternoon, everyone. Welcome to day two of AI Launchpad. Please, can you confirm if you can hear me? If my voice is audible, if I'm visible? Hey, Nahid, hi.
Hello.
Hello. I can already see a lot of you joining in, so we'll give everyone another minute or so to settle down before we begin. My name is Mohit, and I will be your host for today's session. If you were with us yesterday, welcome back. And if you are joining us for the first time, we are really glad to have you with us. Before we get started, let me quickly recap what we covered yesterday and what we are going to learn today. All right. Yesterday was all about building the foundations of modern AI applications. We started with RAG, from LLM foundation to production grade RAG systems, where Manu walked us through how retrieval help large language models generate more reliable and grounded context aware responses. After that, Parijat took us through multi-agent systems and showed how multiple AI agents can work together, each specializing in a different task to solve much more complex problems than a single agent can. Today, we are going to take the next step in that journey. Our first session is on voice AI agents, where we will understand how conversational AI are designed and built for real world use cases. And in our final session, we will explore evaluation and observability, how to measure, monitor, and continuously improve AI systems once they are deployed in the production. By the end of today, you will have a complete picture on how modern AI systems go from an idea to production-ready applications. Before we jump into the technical session, let me quickly take you and tell you a little more about Interview Kickstart. Interview Kickstart has been helping software engineers and technology professionals upskill and grow their careers for more than 11 years now. Over the years, we have had 27,000 plus enrollments, built a network of around 700 plus instructors from FAANG and leading AI companies, and created leading path across 18 technology domains. What makes us different in that our program are designed and taught by professionals who are building these systems every day. The focus is not just on learning concepts. It's about building practical skills, solving real world problems, and helping professionals prepare for the next stage of their careers. That's exactly why we created this launchpad, this AI launchpad, to help professionals understand where AI is headed, what skill matters, and how they can start building with AI in a structured way. And with that, let's get started with our first technical session. I'm really excited to introduce our first speaker for today, Nahid Faridi. Nahid is a principal software engineering tech lead and manager at Microsoft, where she leads AI security, privacy, responsible AI initiatives from Microsoft 365 Copilot and Office. She also brings experience from Google Cloud and Capital One, and currently serves as an adjunct professor at UC Berkeley. In today's session, she will help us understand how voice AI agents are designed, how they work behind the scenes, what it takes to build conversational AI applications for real-world use cases. I'm sure it's going to be a fantastic session. If you have any questions during the session, please use the Q&A section. We'll collect them and answer as many as we can towards the end. Before we hand it over to Naheed, we would love to know little more about everyone who is joining us today. I'm launching a quick poll on your screen. Please take a few seconds to submit your response. It will help us understand on how many of you attended yesterday's session, how many of you are joining us today for the first time. We'll give about everyone a 30 second to respond. And now, with that, without any further delay, I'm going to hand it over to Nahid. Nahid, welcome and over to you.
Hello. Yeah, thank you so much. Thanks for the
Let me
invite.
put my screen once, just a second, so that you can take over. Yeah,
Great. Perfect. So hopefully you can hear me, you can see me,
yes,
and you
Nahid,
can
all
see
good.
my screen.
I get a
Awesome.
lot of people saying yes, so we are golden. Let's go.
Awesome. All right. Welcome everyone. Let's get to the content. So today's session, I'm going to talk about voice AI agent, basically multimodal and conversational agents. Our goal is to build a voice AI assistant in 11 labs. And so we want to master all the concepts, we want to decode the architecture, and then watch an agent, voice assistant agent, get queried live here. So, yeah, we have basically five parts. First, I'll give you some theory, what multimodal agents are, and we need basically everyone on the same page about what multimodal means. And then the second part about voice agents and pipelines. We'll call like speech to text and text to speech, the difference between chain pipelines and then native speech-to-speech solution that we are proposing in 11 labs. And then we will talk about the problem. We're basically building an IK course advisor and we will want to query it live. And then we will decode the architecture. The main thing in a lot of interviews is that you need to draw an architecture and you need to justify your choice of architecture. Why do you go with a multi-agent situation? Why do you need an orchestrator node? What is the reason behind using RAG knowledge base in one of your nodes versus not using in other nodes? So learning about like why it an architecture works, nodes, edges, prompts, and knowledge bases are important. And then we'll talk a little bit about guardrails and best practices. And then the next section will look into observability, will be by the next instructor. So multimodal, we start with the general concept here. Voice is one modality of many. Um, so basically, here is like a clean definition. Traditional AI deals with one input type, one output type. Multimodal AI reasons and generates across several modalities in one pipeline. And by one pipeline, we mean like in a unimodal system, you have separate models, one for text, one for image, one for audio. In multimodal pipeline, a single model architecture, usually, for example, a transformer with modality specific encoders accepts, different heterogeneous inputs and projects them into a shared, space and reasons across them jointly, and the focus is on the cross attention layer in the transformer here. So you can see different modalities in this slide. For example, text, which is prompts, documents, chat, tokenized at a subword level. And you can see audio and voice, speech, tone, prosody. Audio is fundamentally different from text because it's a continuous signal, it's a waveform. We have image, screenshot diagrams, then they're usually processed through vision encoders like VIT, vision transformer. Video is sequence of image frames plus an audio track on top of it, so it's inherently multimodal even as a single input. And then structured data, tables, metrics, JSON files, and these get serialized into text tokens, but the model needs to understand hierarchical structure. So here's the key insight. Basically, a single conversation can span several modalities. You speak, and that's audio. The agent reasons, that's text internally. It responds with voice, that's audio again. And in one turn, you have basically crossed three modality boundaries. And it's critical that the model needs to maintain a shared, representation across all of these modalities. So that is what we mean by pipeline. We mean that, the model accepts multiple inputs and can process them along the way. So you can see different generations from unimodal to multimodal. And so generation one was text only, not too long ago, only like 6 years ago, 2020 to 2022, GPT-3 era. They were basically decoder only transformers. They were text in, text out, and basically they were text generators given a sequence of tokens, predict the next token. They had powerful reasoning with text modality, summarization, translation, code generation. The second generation was text plus image, GPT-4V or Gemini, and the architecture basically changed. There is usually a pre-trained vision encoder this time, and it was added as a front end. Images get projected into the same embedding space as text tokens through a learned projection layer. And then the transformer then attends over both image tokens and text tokens jointly. The third generation is voice using pipelines. This is where it gets directly relevant to today's session. Three separate models chained in series, and we'll discuss the chain of models. Um, and basically, the consequence of these chain models is that the information is lossy at each boundary. Uh, Over each, chain, each step in our change that we go through, we may lose some information. And so the other thing is that the LLM needs to reason on emotionally, kind of like blind input. And these are all, challenges that has been resolved by now, like today's tools. And then the fourth generation, 2025 to now, it's basically a paradigm shift. Audio is processed natively. The model uses an audio tokenizer, usually encodec or sound stream, and it converts raw waveforms into discrete audio tokens. And these aren't word tokens, they're compressed representations of acoustic signal. That is why we can say it can have like emotions, and we can have speaking rate, and we can have, both semantic content and like audio um, representations. So there will be zero information loss at the modality boundary in the new generation, and that is really novel, and that is basically really groundbreaking. So we are basically building in generation 4 today, where the model hears your voice rather than a transcript of it, and 11 labs operates in this space, and they have a flash model process audio natively with about like only 75 milliseconds um, to process the information. So um, trying to monitor the chat. Okay. All right, perfect. So yeah, from multimodal to voice, we have established what multimodal is and how it has evolved. And so there are different reasons, why voice wins. First is, the latency standard. So usually, anything over 1 second feels very robotic. And in human to human conversation, the average turn taking gap is about like 200 milliseconds. So latency is really important. And 11 labs target is about 75 milliseconds to first audio byte. And it's engineered to be faster than the human turn taking gap. The user hears the response begin before they even expect a human to start talking. The second one is that voice carries signal that text loses. For example, tone, hesitation, urgency. Technically, these are encoded in a paralinguistic feature, pitch controller, jitter, shimmer, speech rate, pause duration. For example, a frustrated speaker has higher average F0, which is pitch contour. Um, and there are a lot of, hesitant speaker like myself, for example. I have a lot of or rising intonation or declarative sentences. So that is really important, and that is something that the model can detect and can generate accordingly. The third reason is that users don't want to type. Voice meets people in motion, on calls, in hallways, on mobile, and the information throughput of speech is about 150 words per minute for a natural conversation, whereas like in typing, it's only about like 40 to 50 words per minute in terms of typing. So that's basically 3x input bandwidth that we have for voice. And then the last one is reactive to proactive. Voice agents manage, turn taking and interruptions like real conversations. It requires, voice actively detection. Um, Model that runs in parallel with text-to-speech model. And when it detects, the user starting to talk, it triggers an interrupt, and then the text-to-speech output is flushed from the audio buffer. So basically, we are running inference on incoming audio in real time, but also simultaneously streaming outgoing audio. Text chatbots don't have this problem because typing and reading are inherently non-overlapping. Um, so voice agents, basically there are real world examples of voice agents. I'm sure you have seen it. The takeaway basically here is that voice AI isn't a future technology. It's being used right now across different industries, customer service, healthcare, financial service, education. And the companies deploying them are seeing real result, faster resolution time, reduced operational cost. You can see many like customer facing roles are now being replaced by these AI audio voice agents, and there's actually more improved customer satisfaction due to that. So this is a real need here. So let's start by the first building block of what is a voice pipeline and how 11 Lab is facilitating it. The first building block is basically we have first the raw audio. It's a waveform stream. Maybe it's sampled as like 16 kilohertz for speech recognition, and then it goes into an acoustic model. Technically, what the acoustic model does is that it converts, short overlapping windows of audio, for example, 20 millisecond frames with 10 millisecond stride into a sequence of feature vector. Older systems use, what we call mel frequency substral coefficient MFCCs, and modern systems like Whisper use log mel spectrums, 80 frequency bins. Basically, they can capture, they can reduce the noise to signal, sorry, they can capture more signal to noise, and they can capture more features from audio. And then, they are fed to a language model. They take those, the different phonetic probabilities, and they resolve ambiguities. And the acoustic model might, say this sound is 60% likely to be, this person, 40% likely to be this person. And the language model uses context to decide. And so it generates, some word sequence using, decoding and applying Ngram or natural language model scores to rank the candidates. And then there's a decoder that handles punctuation, casting, timestamp, and formatting. And basically, the output is going to be a clean transcript, like how long is the system design course? Will the recording be available for this master class or not? Something like this. Um, so a good speech to text model handles background noise through, subtraction, noise robust training, and learns, the domain vocabulary through subword tokenization. It can handle unseen terms. It can even be able to differentiate between, different voices when multiple people are talking, and learn, how to synchronize text. So basically, what is lost here is that the critical point basically is that we may permanently lose tone, hesitation, urgency, emotion. And why are they lost? Because the acoustic model's output space is phonemes, so phonetics. discrete linguistic units. So the energy or like the speaking rate, etc., these may not be, these will be available in the input, but they will not be available in the output. Um, so this is a fundamental information bottleneck for any pipeline that starts with speech to text, basically. The second building block, which is text to speech, how the agent's text answer becomes spoken audio, is basically we do have a response text. For example, it's an 8-week live cohort. The cost is $2,000, and it goes, through text analysis. Is the stage is like a little bit more complex than it sounds. We have to handle abbreviations, numbers, dates, etc. And then there is like what we call after text analysis, there's a prosody model. This is where the magic of natural speech happens. Prosody model predicts three things. For example, pitch contour, the duration, how long each phoneme is held, which controls the speaking rate and emphasis, and then the energy, the loudness profile. Modern prosody models use attention-based architecture, for example, faster speech, and they can model, long-range prosodic dependencies, for example, intonation at the end of the sentence. And then there's usually the neural uh, vocoder. This converts, the spectrogram produced by the prosody model into an actual audio waveform. So there used to be like WaveNet, they were autoaggressive, generating one audio sample at a time. And then there are modern ones like Hi-Fi GAN or Big V GAN, which are GAN-based models, and they generate waveforms in parallel, which basically achieve real time or faster than real time synthesis for us. So yeah, then, there are two critical points. One is like what separates great text to speech from robotic text to speech. Basically, that is, the speech patterns and the stress, the rhythm, and 11 lab models are trained on massive voice data sets that can capture these, natural statistics of human speech patterns. And the second one is like the streaming. First audio byte should play before the full sentence finishes synthesizing. So speed really is important here. So we have, the chain pipeline. We have to chain all of the building blocks. Classic, gentry way to build a voice agent, a speech to text, LLM, text to speech, three independent models in series. And we can look at, the latency. There are different models that has been, used for these cases. Speech to text, for example, Whisper, 400 millisecond. LLM, GPT or Gemini, 600 millisecond. Tokenization, Descript, there's a lot of steps. And then text to speech, 300 millisecond. So it will be about 1 to 3 seconds. And these are even optimistic measures, so which is not very natural. Um, that is because, there are a lot of steps to go through. Latency of each of these phases. We can't start the LLM until speech to text is produced the result. We can't move to the next step. These are all serial steps. So three different stages. And there are also like three different failure surfaces. What if the API, what if we have rate limit, things like that? How can we correlate all of the information? There's no native, turn taking in this case. That is the hardest problem to solve in a chain pipeline. Um, but let's move to, 11 labs, and because that is what 11 labs is solving, speech to speech, one integrated platform instead of three glued services. And if you look at the architecture in this slide, inside 11 labs, you have, four tightly coupled components: transcription, integrated using the, scribe model, turn taking, a voice actively detecting model that continuously classifies audio frames as a speech versus non-speech and detects end of turn boundaries. We have LLM reasoning, It can be connected to different, RAG, knowledge base tools, and then speech out at 75 milliseconds to first byte using their flash text to speech model. So the flow is that you speak, you hear, but technically what makes this fast is co-location and streaming between services. If you do the pipeline by yourself, the STUTI speech text result has to be serialized, sent over the network, deserialized by LLM service. Here, the speech to text output feeds directly into the LLM input buffer using a shared memory, so no networking hubs. So there are a lot of key architectural advantages. You make one API call, one SLA. From an operational standpoint, you monitor one service, one set of metrics, one error budget. Turn taking is native. Their model runs continuously on the incoming audio system, even while the text-to-speech is outputting audio. When it detects a speech onset from the user, which takes, about, let's say, 150 milliseconds, it triggers the interrupt, and then the text-to-speech audio buffer is flushed, and then the LLM generation is canceled. So you can see how interruption even works in this case. And then the speed, 75 milliseconds, is very impressive. Um, and so their LLM starts, generating tokens. The first audio chunk is maybe like generated in 10 to 20 milliseconds, and then in less than, 80 milliseconds, they can generate the first audio byte. And the user starts hearing the response before a chained pipeline would have even finished transcribing their question. So it is very impressive. And here's a side-by-side comparison of the chained pipeline versus 11 labs in this case. So you can see latency to first audio, APIs to manage is smaller, emotion and tone preserved through a loop, it may be discarded in a chained model. We have interruption handling in 11 labs. It has built-in turn-taking model that handles barging interruptions natively. It can even have handle multi-agent orchestration. If it's chain, you have to handle it yourself. You have to build the orchestrator. You have to build everything. But in 11 labs, it's easily built through a node. And then the failure surfaces is in 11 labs is one. So, uh, so yeah, that is basically the comparison here. There are cases where chain pipelines are needed. For example, when there's like regulated industries, healthcare, finance, where you need an audit trail showing exactly what was transcribed, exactly what the LLM generated, etc. A chain pipeline gives you that artifact at each stage. So you have to always make your choices at the design time and at the architecture time in this case. Um, all right. Taking a look at the chat, monitoring. Okay. So this is basically 11 Labs platform at a glance. And you can also try for yourself. I'll show the 11 Labs demo in a bit, but you can see there are like can have several agents. You can handle several agents. You got speech synthesis, voice cloning, conversational AI platform that we're building today. So do not limit yourself to just creating an agent. Um, but for our purpose, the key capability is the conversational agent feature. And that's what we are building today. We want to build an IK course advisor for you. Um, all right, so the feature that we're building, so we want to basically build a conversational agent. It will have a voice engine, speech to text, text to speech, turn taking is handled. There is no need to write any audio code, and you don't need to integrate Whisper endpoint. You don't need to configure audio codec. negotiation. You don't need to manage WebSocket. All of this is handled. We will have an LLM orchestration. We can choose Gemini or GPT or Claude for reasoning, and it's a significant architectural choice. You can select models based on the task. Um, and you can have like latency trade-offs. Claude is better for nuanced reasoning and longer context. GPT offers a stronger general purpose performance. You can assign different models to different sub-agents in your workflow as well. You may choose some smaller model, cheaper model for your orchestrator, more advanced model for the tasks that need more reasoning. You will have RAG and knowledge base. You can upload documents. The agent retrieves per question. And under the hood, it's a useful, kind of like RAG pipeline. Document ingestion with chunking, embedding generation using a sentence transformer, storing it in a vector index. All of this is handled through 11 labs. And we will have like a visualization of our workflow. You can visually see your multi-agent builder. You can see the nodes, you can see the edges, and it's a directed graph editor where nodes are agents, instances with their own prompts and knowledge-based buildings. And then you can also have like post-call analysis, conversation level analytics, turn count, latency percentile, routing path taken, tokens consumed, cost per call. These are all the observability layer that is built inside and is enabling you for auditing purposes, metric handling, and yeah, evaluation basically side of stuff. So yeah, that is the kind of like the full platform architecture. And so it's kind of like a data flow topology. Audio comes in through a WebSocket connection, and it's a bi-directional streaming, not request response. The client sends audio frames continuously, and the server sends audio frames back continuously. It's a full duplex communication. And inside the platform, the components are connected via in-process streaming. There are no network calls. The speech to text output, text tokens stream directly into LLM's context window, and the LLM output tokens stream directly into text to a speech synthesizer. So this basically eliminates the need for serialization, deserialization, overhead, and that is the main cause of latency in the chain pipeline, basically. And the knowledge base and workflow engine sit alongside the LLM. It's accessible using function call um, interfaces. When the LLM decides it needs to retrieve information, the RAG query happens in process, not using an external API call. So all of the co-location is the kind of like the engineering secret behind the great latency number in 11 labs. So um, let's now see what happens on every single turn of the conversation. The first step is transcription. It's accurate even with noise and accent. 11 Labs scribe model handles multilingual input. I even have friends who use for Portuguese with different accent of each city in Portugal, which is pretty impressive. So it means they have a huge database to all accents and all conversations and all types of, different ways to speak. It has capability for background noise suppression, domain vocabulary, and the output is a text transcript of the user's utterance with word level timestamp and confidence store. Then it will handle turn taking. This is technically a binary classification problem that runs on every audio frame. Is the user done speaking? And the model has to distinguish between speaking and pausing, mid-sentence hesitation, thinking, breathing, or end of turn. The user has finished their thought and expects a response. So the difference between, for example, a 300 millisecond pause and think and a 300 millisecond end of turn is subtle. It depends on prosodic cues like falling pitch, completed synthetic structures, speaking rate declarations, something like this. Getting this wrong in either direction is bad because we will jump right in the middle of the user's sentence. And then there is reasoning, intent classification plus context plus retrieval gives us the response. Technically, the LLM receives the transcript plus the conversation history plus the system prompt plus the workflow state, which means which agent is currently active, which sub agent is currently active, and it decides, does the query belong to my domain or should I route it? What information do I need from my knowledge base and how do I synthesize the retrieved chunks into a natural spoken answer? So it's a simple single forward pass through the transformer, but it's basically doing classification, retrieval, and generation all at the same time. And then finally, we have synthesis. We need a realistic voice output, and the generated text is streamed token by token into text to speech pipeline, which starts producing audio from the first few tokens. Chunk-based streaming means the user hears the beginning of the response while the LLM is still generating the end, which is pretty impressive. So the magic isn't any of these. It's all four happening under a second on every turn invisibly. So each of these is a hard machine learning problem on its own, and running all of them concurrently with real-time latency constraint make it, pretty impressive. Um, the second capability that we want to talk about is RAG, how the agent knows your facts, retrieval augmented generation, which I think you learned about yesterday in the first session. The agent retrieves your uploaded documents instead of guessing from training data. So in this case, user asks, for example, how long is the system design course? And it gets transcribed and becomes a query for the retrieval system. Then there is usually a semantic search. The query text is embedded using the same embedding model that was used to index your knowledge base. It's critical. It needs to be the same model, and for both indexing and querying so that vector spaces are aligned with each other. We cannot search for what we have not inserted into our vector database. So the query embedding is compared against all chunk embeddings using cosine similarity, KL divergence, whatever similarity metric. Then we'll achieve top K chunks, for example, 3 or 5K, top 5 or top 3 chunks are returned, and then they are ranked using a ranking technique by relevance score. And then we have retrieval. The knowledge base returns, matching content, for example, 8 weeks, live cohort, mid to senior level. These are raw text chunks extracted from the document along with some metadata, like which document they came from, where were their position in the document. So now we have to really, generate that response. Grounded compose is where, RAG differs from pure retrieval. LLM doesn't just return the retrieved chunk verbatim, it synthesizes them into natural language answer using the retrieval content as the facts. So the system prompt instructs the LLM to ground its answer strictly on the retrieved content, and if the retrieved chunks don't contain the answer, the LLM should say, I don't know, I don't have this information. And then we go to spoken answer, which basically says, oh, it's an 8 week live cohort program. And so basically you'll notice the transformation. The source document says duration 8 week, format live. So it's a JSON probably. And the LLM converts it, to document style text into conversational speech form. So it's voice first synthesis. The key insight is that the agent isn't, reciting a script. It's looking up the answer live from a document that you are controlling. So it's really important to have good information. If you have updated information, you need to re-upload your knowledge base, basically. So, and that is actually brings a lot of flexibility. You don't need to change any code. Don't need to redeploy. You don't need to retrain the model. You'll just update your RAG information or knowledge base. Sometimes answering is not enough, and RAG only handles, answering questions from documents. But what about when the agent needs to act, not just answer? And we call that tool calling through model context protocol and API integrations. Um, the agent can execute, real actions mid conversation, check a CRM, book an appointment. Technically, this works the same way function calling works in text based LLMs. The model generates a structured output, which is a JSON object with function name and arguments instead of text response. The platform intercepts this, executes the API call, and injects the result back into LLM context for the next generation cycle. So one great feature called out here is called pre-tool speech. And while the API call is executing, which may take 1 to 3 seconds for an external service, the agent says, let me check that for you. This is a UX pattern that eliminates kind of like silent, like this awkward silence or dead air. The text to speech generates a filler response while the tool call runs in parallel. And without this, the user sits in silence, wondering like what happened here, and then results right back as working memory. The agent carries across turns. Technically, the tool response is appended to the conversation history as a system or tool message, and this means if the agent looked up your enrollment status in turn 3, it still knows that status in turn 7 without requiring. So yeah. All right. Okay, perfect. Monitoring chat, still no questions. Feel free to put your questions in Q&A. All right, so now let's move to the problem statement and our live demo. We want to build an 11 Labs conversational AI voice agent that acts as a virtual course advisor, answering live spoken questions about the course catalog by reasoning over knowledge base. The agent must handle 4 categories of queries, each of them testing a different capability. Direct lookup. One is how long, for example, is the system design course. This tests basic RAG retrieval. The query maps to a single chunk in the knowledge base. The agent retrieves it and then synthesizes it to a spoken answer. It needs to be able to cross-reference who teaches it. This tests conversational memory and conference resolution. It refers to, whatever course was discussed in the previous turn. The agents needs to carry context across turns. The LLM's conversation history must include the previous Q&A so it can resolve it to system design course. And then company questions, for example, what is interview kickstart? This tests routing to a different specialist, which has completely different knowledge base. The greeter must classify this as general IK question and route it to the IK specialist. And then we will have some graceful fallbacks for anything outside that data set. And this tests, the hallucination guardrail. If someone asks what is 2 plus 2, what's the weather, the agent should not attempt to answer from its, parametric knowledge. It should recognize the query is out of scope, and it needs to respond honestly. Some stuff are out of our scope, enrollment, payment, etc. If you try it, later on, you can always expand scope, and it's going to, it's much harder to constrain a system that's, already overboard here. So a little bit about our knowledge base. We have, 3 knowledge bases. The 3 documents power this agent. One of them is course catalog, which contain all interview prep courses and agentic AI programs. Who each is for, we will have, so this powers the course specialist. From a RAG perspective, this document will be chunked into segments of, for example, 500 to 1,000 tokens. And the embedding model will create dense vector representations of each chunk. And when someone asks, how long is the system design course, the query embedding will have high cosine similarity with the chunk that contains system design course. We will have instructor directory, instructor profiles, what they teach, topic to instructor mapping, and how mock interviews run. And it powers the instructor specialist sub-agent. And this document, has a different structure. It's entity-centric. It's organized by person rather than by topic. So the chunking strategy is different. If instructor profile spans multiple paragraphs, the chunking needs to keep each profile as a coherent unit. It shouldn't split one instructor's biography into multiple chunks. And then we have a general information, KB, company background, and pricing policy, refund guarantee, etc. And this powers the IK specialist this time. If the pricing information isn't in the document, the agent can't hallucinate and generate a price. So one architectural decision, or one architectural note that we have to make here is that each knowledge base is scoped to exactly one specialist, KB to course, KB2 to instructor, KB3 to IK. And this scoping is a structural guardrail that we want we will go in depth. Success criteria, and the agent must answer naturally, answer only from the knowledge base, or say, I don't know, I don't have that information. The routing must work correctly. Course questions go to course, instructor questions go to instruction, the rest of it to IK specialist. It should survive follow-up questions. The agent shouldn't be fragile. It should stay responsive about 1 or 2 second round trips with natural turn taking. So before we run the demo, walking you through what happens under the hood on every question you speak. So there's raw audio stream, and then we have the voice engine transcribing the audio and detecting end of turn. Then the step 3 is LLM, classifying intent, running RAG retrieval. Step 4 is the knowledge base, matching, for example, course info, returning that information. And then step 5 is that you will hear speech synthesized at about 75 milliseconds. And then the round trip is about 1 to 2 seconds. The step worth calling out to this forum is the RAG step. The agent isn't just, reciting a script, it's pulling answer live from a document that we have uploaded. And, we can keep changing the document if you want. All right, so let's go to the demo. Just making sure that you see 11 labs here. Let me just refresh, make sure. All right, so this is 11 labs. And so you can see you can have multiple agents in one account. This is just one agent. The cool part is that it's similar to like any software development practices that we learned about, is respected here. For example, you can have multiple branches. You can see like we have 2 branches here. You have an agent here, and the agent can have like a system prompt. You can see, let's say, identity and context. You are Ava, virtual course advisor for interview kickstart. Tone and delivery speak like a person talking, not a document. 2 or 3 sentences for most answers, plain natural spoken. There are some grounding rules that says every factual answer must come strictly from knowledge base. So you can see there are hard rules. Never state a price. Interview Kickstart does not publish tuition. For example, never promise a job. Never invent an instructor. Never say which named company or specific instructor works. So there are, some rules that you can define here. You have to be honest. If a caller raises a criticism, respond, respectfully, composure, transparency. And then, there is a first message that you can always ask your agent to have. The cool part is the workflow. We will walk through this workflow in more detail, but you can see that we have a greeter agent, and then we have instructor specialist or course specialist or IK specialist. And the greeter agent's job is to basically um, route the questions into each of these specialists, and each, like, from one sub agent you can also have opportunity to move to other agents as well, depending on, like, look, course question or instructor question. So depending on the type of the question, each of the sub agents can also decide to route to the other agent. As I said, you can have different branches, have a working branch, and then you don't have to necessarily push to your main branch. You have knowledge base, and you can upload as much as you want. You can test your RAG. Here's, for example, one of the knowledge bases. And you can see, the file content here. It's very simple. It takes care of everything for you. You just upload, the source file, and that's it, no problem. So you will have, different knowledge bases if you want to. You can have tool calls. We don't have tool calls in this example. And there are actually dashboards that can help you learn what your agent is doing, how it is being consumed. You can see, the pricing that is used, success rates, agent response time, what sort of conversation it had. And so what I want to show you here is like sample of conversations. I mean, of course, you can try here as well, but just quickly show you, different samples of conversations. It has past history of all of your conversations as well. And, you can play.
Hi, I'm Ava, the virtual course advisor for Interview Kickstart. I can help with our interview prep courses, our agentic AI programs, who teaches them, or anything about Interview Kickstart itself. What would you like to know?
So,
Let's move into the second
how
part.
much does the backend course cost? Just give me a ballpark. I won't hold you
Yeah.
to it.
So I won't play all of it, but asking, how much the backend course is costing. And immediately it says Interview Kickstart doesn't publish a single price because it depends on which program you choose. So what type of courses do you have? So Interview Kickstart offers a variety of courses focused on interview preparation, etc. And, asking about different agentic AI courses, who is teaching, who are the teachers. You can see, it extracted from who is, the teacher, etc. You can also from each call see how much the conversation cost, what sort of, it can do some analysis for you. There's also a window that I believe, if I find it, it will show you what parts of the agent, like, so what route in the agent it has been taken. Hopefully I can find it. I know it has this capability. I don't see it just yet, but it has the capability to find, what flow in the workflow you have gone through. You can also, have different other different conversations as well. So this one, how long is the system design course? And I can tell you about the system design course. So this is basically And there are basically two ways, to test this whole process. One is that, you have like a preview button here, and through the preview, you can either send a message, type a message, or you can just have like a small widget on the side and start a call to your agent. So, and here even you can make a call as well, or you can, just keep typing whatever you want to test your agent for. For example, what courses? Okay. And in this case, it will not, read for you. It will just write for you. But you can choose to, just talk to it as well. So it will immediately detect. So, and it even's like, you can give it instructions to keep you engaged as well. Would you like me to go deeper into any specific course? We can maybe try and find like who is teaching each course. The one thing that I want you to also note here is that you have the capability to select what model you have, and you can also like choose the tone and the voices that you would want to your agent to have. Here we just choose the free model, which is the cheapest one. So that is why you will see a little bit of delay in some of the answers and some of the conversations that we have. Is because we are not using a paid model, and you can choose any sort of agent that you would want to. So hopefully that is interesting to you. All right, so let's move back. And talk a little bit about the architecture. All right, so yeah, let's look at the complete tech stack. So voice layer, audio in, audio out. We used Flash v2.5. Why Flash specifically? It's basically optimized for synthesis with 75 millisecond time to first byte. It's a lightweight voice decoder architecture, and it basically trades a small amount of voice naturalness for significantly lower latency. For a conversational agent where your responsiveness really matters more than studio quality audio, Flash is going to be the right choice. We have a reasoning layer, intent classification, and answer synthesis using Gemini 2.5 as the default. Why Gemini? One is that it has like excellent performance on classification task, which is what our greeter does on every turn. The greeter needs to classify intent into one of the three categories, plus out of scope, and Gemini Flash basically, handles this with high accuracy at low latency. Second, it has the first time to first token, important because our text to speech starts synthesizing from the first generated token. Every millisecond is important here. We have like a knowledge layer, semantic search over documents using 11 Labs built-in RAG layer, as you saw. And the scoping is the key architectural choice here. Each specialist searches only its own document, and this reduces the search space, improves retrieval precision, and we also don't cross-contaminate our results here. And we have the orchestration layer, multi-agent routing using the workflow canvas that I showed you, plus different LLM conditions. So LLM conditions are plain English routing rules. no keyword matching, no regex, no rule-based classifier. The LLM evaluates the condition against the user's last message and returns a Boolean. And this is more robust than regex because it handles paraphrasing, indirect requests, any ambiguous phrasing. For example, when I wrote who teaches it, or tell me about the instructor for the class, or what's the teacher's background, they all match the same LLM condition, even though they share 0 keywords with each other. And the key insight here is that we are orchestrating base models, not training anything, not fine-tuning, no custom model training, no label data set, no GPU cluster, nothing. The entire system is built from off-the-shelf models, and they're wired together with prompts, knowledge bases, and routing conditions. And the skill is basically is in the architecture, not the model. So this is our workflow architecture. Okay. So we have, the workflow visualizer. So we have, these are some sample queries you can ask from the agent basically. For example, how long is the system design course basically tests direct RAG retrieval. The query embedding needs to map to the chunk of in the course catalog document that contains system design duration. Who teaches the data structure tests, the greeter routing accuracy. The LLM condition on the greeter instructor age needs to fire correctly, classifying this as an instructor query, not a course query. So this is really important. Or for example, when we ask what is interview kickstart, it needs to route to IK specialist. The query is not about course, it's not about instructor, it's a general company question. Or for example, when we ask, what is 2 plus 2, it basically tests the hallucination guardrail. The agent should not attempt to answer this from its parametric knowledge. The correct behavior is to say something like, I can only help with questions about IK courses, instructors, and programs. And so you can see the whole, processing pipeline as well that we went through. You speak, speech to text, turn taking, reason, text to speech, and then you will hear. The workflow graph is the meaty part, the main diagram. It's a directed graph and it represents the conversation state machine. You always have a start node. It's usually accompanied with a flag icon and it's the entry point. It fires automatically when a new conversation begins and then it automatically transitions to the greeter. And then the greeter box has 3 annotations that capture the entire design philosophy of the router pattern. Intent router, which classifies and hands off. There is no knowledge base attached to greeter. It never answers anything. Technically, the greeter runs only the intent classification, a single LLM inference that evaluates the user's message against an outgoing edge condition and determines which specialist should be called here. Because it has no knowledge base, the RAG pipeline is skipped entirely in this node. And then from the greeter, we have, 3 LLM conditions that you can see. One is the left edge, which is the course specialist condition that is, asking about course structure. The course specialist scope is listed right on the node. You can see, modules, weeks, topics, subtopics, formats, and then it's also connected with dash to dashed line to KB1. And the right one is the IK specialist condition is asking something general. You can see asking something general in the condition. And the scope is what IK offers, policies, enrollment, frequently asked questions connected to KB3. And then in the middle, we have the instructor specialist condition is asking about an instructor. And the scope is, who teaches what, background, course-wise experts connected to KB2 basically. The critical part is that we also have, cross-routing edges between specialists, and you can see, them as dash line connections with different conditions saying each pair. So between course specialist and instructor specialist, you can see it will be bi-directional basically, asking about course, asking about instructor. So same pattern between course and IK, between instructor and IK. So in the graph theory, this is a complete directed subgraph among the three specialist nodes. Every specialist has a directed edge to every other specialist, and basically the number of edges is going to be 3 by 2 6 cross routing edges. And then we also have an end node. It's usually with scissors icon, and all of the three edges lead here, one from specialist, all with the condition that user indicates finished, user indicate finished, user indicate finish, user indicate finish on this one. And the conversation state transitions to end and the session closes. And our takeaway from this diagram is not just a picture, it's a formal specification of a FSM or finite state machine. And the nodes are states, the edges are transitions, LLM conditions are transition guards. And you can see basically all of this is what matters nowadays. We have to be able to design architectural stuff. So yeah, this is just a summary, what each node is doing, the start node, the greeter node, router. Each of the other ones are the specialist ones in this case. And then we also have like what each of, the edges do in this case. Greeter to a specialist, a specialist to a specialist. So total we have 13 edges, and every edge carries an LLM condition. It's basically a plain English rule evaluated against the user's last message. For example, user is asking about an instructor background. Technically, the LLM receives the condition text plus the user's message to decide where to go next. So we use LLM because it's works much more better than just keyword matching, regex, etc. Now let's ask some good architectural questions. I want you to think about it. I'll just wait a couple of seconds. Think about it. Maybe write your answer in chat. Why do we use a greeter node at all? What could go wrong with only the three specialist nodes? So maybe you can just ponder a little bit, think about it. I'll give you a little couple of seconds before giving away the answer. Feel free to put your answers in the chat. So the greeter is a dispatcher. It's not a concierge. And it has, one job only, right? Your only job is to understand what the caller needs and route them. This is single responsibility principle applied to agents. The moment the greeter starts answering questions, it becomes a generalist, a single agent doing classification and retrieval and synthesis. So that recreates the exact monolithic agent problem, multi-agent design slows. So you may get attention dilution across tasks. The prompt becomes longer and more context, and the agent classification accuracy drops. It doesn't need it doesn't need any knowledge base. So because we don't want it to hallucinate, it's a structural constraint, not a behavioral one. A node with no knowledge base attached has no document in its retrieval index, and when an LLM generates the text, there are no retrieve chunks to ground the response. So it, literally cannot produce a domain-specific factual claim. And you can compare it to other specialist agents. It can handle, vagueness with questions. If someone says, give me an update, ambiguous intent that could map to any specialist, the greeter asks a clarifying question. This is a disambiguation pattern common in dialogue systems rather than guessing and routing to the wrong specialist here. And so the design principle in multi-agent systems, in distributed systems, is that you need to route first, answer later. So it's similar to load balancer or API gateway. We dispatch the request to the right backend, but never process them ourselves. The greeter is your API gateway of the multi-agent system here. So this is the specialist node deep dive. We'll just, basically say what should be the system prompt, what is your knowledge base, what sort of LLM reasoning you need to do. And so, for example, this is the course specialist and the different prompts for retrieving and the jobs of each of the phases. So another question, why, do specialists get only their own knowledge base? Wouldn't it be simpler to give every agent all three documents? Again, let's spend a little bit of maybe a minute just thinking. Feel free to post your answers in the chat. If we give all three documents to all the agents, it will overlap the domain. Yes. Effective response. It will take more time. That's a good question. Oh, limit the DB search. Yes, vector database search is expensive. These are all great pointers. Right, so basically, knowledge base scoping is a guardrail, and it's not a limitation, right? So, for example, KB1 course catalog connects only to course specialists, KB2 only for instructor, then the third one only for general information. As you mentioned, three reasons. One is accuracy. Retrieval over one focused document beats retrieval over three mixed ones. Why is that? Semantic search returns top K chunks by cosine similarity. So if you're searching one document about courses, all top K results are course-based related, high precision. If you're searching three mixed documents, you might get two course chunks, one instructor chunk, and two general chunk in your top five. So there will be irrelevant chunks and they will go into your LLM context and they will result in, confused answer. And this is called the retrieval noise problem, and scoping eliminates it architecturally. The second one you mentioned, no domain bleed, we call it. The course specialist can answer the instructor trivia. It physically can't because KB2 isn't in its retrieval in text. So this is a structural isolation guarantee. You can't prompt engineer your way past it. Even if a user asks the course specialist who teaches what, the specialist has no instructor data. It will either say, I don't have the information, or if cross-routing is configured, it will route to the instructor specialist. It cannot produce incorrect information. And then debuggability. Wrong course answer. You know exactly which node and which document to inspect. The debugging surface is, one agent plus one document. In a single agent setup with all three documents, a wrong answer could come from any of the three documents. You need to inspect the retrieval results from all of them. So a scope architecture makes root cause analysis really easy. And then what about, the cross-routing edges? What are, the specialist to specialist edges for? So a caller is in course specialist and ask about instructor. What happens without cross-routing? So without cross-routing, without cross edges, who teaches this? This is outside my area, stuck. The user has to hang up and start over. This is called a dead end state in a conversational state machine, a state from which the user cannot reach their desired outcome without restarting. Dead end states, are the number one UX failure in the multi-agent systems. If we have cross edges, the workflow detects the instructor question using an LLM condition and then fires the transition to the instructor specialist, and the conversation continues seamlessly. The caller never notices the handoff, the conversation history carries over, and the instructor now also has full context about what was discussed in the course specialist, so it knows if the user was asking about the instructor for the system design, or not just who teaches, like, because it has to make this cross reference using the attention network, using the transformer, connects who teaches it back to, let's say, the system design course. So the rule of thumb is that every specialist needs n minus 1 cross edges, where n is the number of specialists. The total cross edge count is n multiplied by n minus 1. So with 3 specialists, 6. With 5, 20. So basically, there's like a quadratic growth in the cost of a full mesh. In practice, we don't always need the whole full mesh. If two specialists are unlikely to cross-reference each other, you can omit the edge, but for our three specialist system, full mesh was manageable and it was easy to build basically. And then we have to also, make some routing decisions. When a user asks a question, say they're currently in the course specialist, the system evaluates all outgoing edges and determines one of the 4 outcomes. Should I stay and answer? The question is about course. All outgoing LLM conditions evaluated to false, so no transition is needed. The agent stays in the current node and answers from KB1. This is default behavior. The agent only routes when an agent condition explicitly matches. Then it may have to route to instructor. The LLM condition asking about an instructor evaluates to true. Conversation status transitions to instructor, and the conversation history is passed along and it's provided as context. It may have to route to IK specialist. The LLM condition asking some general question, same mechanism to above. And sometimes we have to, to repeat the request. Sorry, could you repeat that? The transcription confidence was low or the utterance was too short to classify. The agent stays in the same node and asks for clarification. So you have to know that the key distinction here is that misheard is not equal to misrouted. These are two completely different failure modes. Unclear audio is low speech to text confidence, which gets a repeat request and the agent stays put. A clear out of domain question gets a route, the agent transitions. The speech to text confidence score can be used to distinguish these two situations. Below a threshold, let's say 0.6, ask for repetition. Above the threshold, evaluate routing condition, and then conflating these two would cause the agent to route on like some sort of garbled audio and ask for repetition on a clear, cross-domain question. So we have to be very clear about the threshold that we want to define here. Another question, why a global prompt and per agent prompt? Why not just write one big huge prompt per agent and with everything in it? So, any guesses? So, it's basically policy versus job description. The global system prompt is like the company policy. It applies to every node. And the sub-agent prompt is like a job description. It applies to one node. This is a prompt inheritance architecture. So the global prompt is the base class. Sub-agent prompts are the derived class that add a specialization. At runtime, each agent's effective prompt is the concatenation of the global prompt plus the sub-agent prompt. And the global prompt contains KB grounded answers only, voice first, brevity, repeat request feedback. These are system wide invariants that must hold across every agent. The sub-agent prompt contains role declaration, domain scope, answer style. Let's say answer this one short, answer this one longer, and more granular instructions. So the global prompt quotes ground every answer strictly in knowledge base, one or two sentences, be upfront. And there are a couple of constraints: grounding, brevity, transparency. Why do we separate them? It's called the derive principle and consistency. If you embed global rules into every subagent prompt, you have three copies of the same text. If you want to update your grounding rule, you have to do three edits, which risks divergence. If you miss one, the agent starts hallucinating while the others don't. So by factoring out the common rules into a global prompt, you maintain a single source of truth for your system-wide behavior. So every specialist prompt follows the same three-section skeleton. You'll talk about their expertise, what the agent knows about. For the course specialist, what courses are offered, the modules within each course, week by week topics, etc. How they should answer, the response style, pull strictly from the attached knowledge base, short overview first, go deeper only if asked because we are burning tokens, boundaries, where to redirect, instructor question, route to instructor. Not about IK at all, decline in place, don't route. So we first cover expertise, then we cover how to answer, and then we cover the boundaries. Every specialist, same skeleton, different content. So this pattern is reusable. If you even add a fourth specialist, you follow the same structure in their prompts, basically. Lastly, why multi-agent beats one huge mega agent, right? This is a really important question, and you will be asked these questions in design interviews. One is attention dilution. Let's say a 5,000 word prompt covering, three domains produce worse answers than three focused 800 word prompt. Why technically? Because we want to know the real answer. Transformers allocate attention across all tokens in your context window. A longer prompt means each instruction competes for attention weight with more tokens. Research has shown that LLMs follow instructions more accurately when prompts are focused and concise. If your prompt is like 5,000 mega prompt, the model might attend to the wrong domain's instruction when answering a course question, pulling the instructor related guidance. If we have three separate ones, we eliminate the cross domain interference. The other one is knowledge base leakage. One agent with all documents means that retrieval index contains chunks from all three documents. And so there will be cross-domain retrieval contamination in this case, and it's eliminating by KB scoping. Then debugging breaks down. In a mega agent, when the answer is wrong, you need to determine, was it a retrieval issue? Was it a reasoning issue, right chunks, wrong synthesis? Was it a prompt issue, correct information but wrong answer style? And each of these could involve any of the three domains. That's basically three issues in three domains, nine potential failure modes. In a scoped agent, it's one domain with three failure modes. So you can see how your surface is reduced. And then we can also have like modular improvement. If you want to update KB2 without re-indexing KB1 and KB3, that's easy. Change the instructor specialist prompt without touching the course specialist. This is called microservices principle that is applied to agents, independent deployment, independent testing, independent improvement. You can even A/B test a new prompt for one specialist while the other specialists remain the same. And the rule is that if one agent is doing three jobs, it's doing all three worse than a specialist would. This is empirically validated. Every benchmark shows that task-specific prompts outperform general purpose prompts on a specific task. Finally, quickly going over guardrails. Guardrails aren't one thing, they operate at different levels, and the levels have fundamentally different properties. Level 1 is the global system prompt, company policy, uh, KB only answers, brevity, transparency. It's a behavioral constraint. You are instructing the LLM to behave in a certain way. And if effectiveness depends on the model's instruction following capability, strong models like GPT-4, Gemini 2.5, Claude follow these reliably in normal conditions. Level 2 is sub-agent prompt, job description, domain scope, redirection, answer style, also a behavioral constraint, but narrower. This focuses the model's behavior but doesn't physically prevent it from generating non-course like information. Level 3 is KB scoping. This is structural, the strongest type of guardrail that you will have. Each agent physically sees only its own related document. The data, like if they ask about something irrelevant, the data just isn't there. The structural constraints are not bypassable because they operate at data layer, not an instruction layer. The agent can't leak what it can't see. And then we have routing conditions. LLM conditions on edges catch misroutes early. If a user asks course about instructor, LLM condition on the cross-routing edge fires before a specialist generates the response. It's a preemptive guardrail. It prevents the wrong agent from attempting to answer. So level 1 and 2 are instructions. Level 3 is architecture. You should always prefer architecture guardrail over behavioral one. Instruction can fail, but architecture can't fail. All right, so finally, practical do's and don'ts. Lead with the answer. Key fact in the first 5 words. Why? Because voice is a serial medium. The user can't scan ahead. In text, the user's eye jumps to relevant part of the information. In voice, they have to listen. If the answer is buried under a lot of extra information, they will lose focus. Use real numbers. 8 weeks, 5 modules. Vague answers like it takes a while. There are several modules, sound evasive, and trigger follow-up questions. Keep it to 1 or 2 sentences. It's about like 30 words. It's good enough, 16, 12 seconds to speak. Longer than that, people may lose attention. Design for interruption. You have to think about interruption because people can get impatient. And end with anything else. This is a turn yielding cue. What you shouldn't do is, read the whole document, synthesize, don't dump. Use bullet points out loud, like bullet 1, bullet 2, etc. Attach a KB to the router. Skip the global prompt. So these are, some do's and don'ts. And yeah, finally, recapping, multimodal agents, they perceive, they reason, and then they act. The perceive, reason, act loop with modality-specific encoders basically are the generation 4 of multimodal models that we have. We talked about pipelines and how integrating all of the steps in the pipeline into one single platform using shared memory like 11 labs improves our speed. And we had a demo of the greeter agent for the IK course specialist. We talked about guardrails at 4 levels. And I do want to have like a call to action here: build, document, publish. Package each agent with a README and architecture diagram. Push it to your GitHub portfolio. The architecture diagram you saw today, the workflow visualizer, is exactly the kind of artifact that demonstrates system thinking. So yeah, I'll stop here and try to answer questions in the chat. Thank you, everyone, and I hope you enjoy the next session.
Thank you so much, Nahid.
Yeah.
That was a fantastic session, and I hope everyone enjoyed it. While you are answering some questions in the chat, let me just share my screen. We started by understanding how voice AI agents work, right? How they are designed and what it takes to build conversational AI applications for real world use cases. And I hope this session gave you a good understanding on how those systems come together in practice. Now I'm going to talk a little bit about Interview Kickstart. While you guys hear me, maybe this is a good time to grab a snack, a quick sip of water, or maybe take a short break before we begin our final technical session. I know a lot of you are not just looking for 2 days of learning, you are looking for something more concrete, something that you can carry forward in your career and use it to future proof yourself in the age of AI. So, to begin that conversation, I'm going to play a short video by our co founder, Ryan. I'm sure a lot of you will be able to relate to what he wants to say. Let me just share my screen once. Here we go.
AI is no longer the future. It is here, it is the now, and it is the skill that every single person in technology needs to be on top of if you want to survive and also thrive in the next many years. This AI wave has unlocked unprecedented opportunities for all of us. If you look at all the hiring over the last few quarters, you see that all the growth has really come in AI roles and now increasingly so in AI-enabled roles. Far more importantly, the compensation that we are seeing here, going up to $1 billion in some cases, is unheralded. It's unprecedented and nothing that we've ever seen before. We ourselves at Interview Kickstart are constantly seeing our own alumni who are AI-enabled or have AI and ML skills getting offers that in many cases are $300,000 to $400,000 more than their peers simply because they have the AI skill set. The challenge though is that AI is moving at warp speed. It's moving so fast that it's very difficult to figure out both where to start and how to pick a path that is customized, or to use a word often used these days, fine-tuned for you. That's where we at Interview Kickstart come in. We have built a career acceleration platform that helps you turbocharge your career with AI skills. We've been doing this over the last 12 years and I've already worked with over 25,000 working professionals from all domains in tech: software, product, data, ICs, managers, and the entire like. Our approach is unique. We believe that the frontier of AI has moved to the world's best companies and the world's best AI labs, which is why we bring together a platform of over 700 instructors, all of whom who come from the likes of Google, OpenAI, Meta, Anthropic, and other cutting-edge AI companies. Everything that we bring to you is designed, developed, and delivered live by these professionals, and so they bring their frontier lived experience to every single classroom. We also believe that the world has changed. It has moved from an era of passive learning to now active building. And so in each of our programs, you will get your hands dirty. You will build AI projects, all oriented on helping you build an AI portfolio, because that is what is required today if you want to turbocharge your career. Finally, we realize that there is no one size fits all in AI, and AI really needs to meet you where you are at. And all of us are at different levels, have different experience, have different backgrounds. And so we offer a plethora of courses that is completely flexible. They range from 3 months, 6 months, 9 months, 12 months, spend more than a year as well, based on your career goal. They're fine-tuned for every domain. We have 18 to 20 domains that we cover. We have separate courses for ICs, separate courses for managers, and we have versions in pro code, low code, and no code. Bottom line, we want to meet you where you are and work with you step by step as you up level to building a fabulous AI career.
All right, that was Ryan for you. I hope you enjoyed that. Let me just share my screen once more. All right, great. Hopefully my screen is visible. If you can see my screen, just say yes in the chat box. That's great. I hope you enjoyed that. I'm sure a lot of you could relate to what Ryan was saying. At the beginning of today's session, many of you told us that you are looking to layer your existing tech skills with AI instead of starting from scratch. Whatever your domain is, you want to stay in that domain and become AI enabled. We know that. Yesterday, when we asked about the biggest blockers professionals are facing while upskilling in AI, many of you said that you were looking for a structured approach, while others said they were not confident they had the right AI skills to crack interviews at the top technology companies. See, because of all that, you may find yourself in one of these situations that you can see in front of your screen. The first is very simple. AI is moving way too fast, as Ryan also mentioned. The second is there's simply too much out there. I don't know where to start. The third is my role is unique. So maybe AI won't impact it. But if we have learned anything over the last couple of years, it's that AI is changing almost every technology role in one way or another, and new roles are coming all the way together. And the fourth, especially for experienced professionals, is will I have to start from scratch? Many of our learners have 8, 10, 15, even 20 years of experience. And that's one of the biggest concerns they have. The good news is you don't have to. They are simply myths. You don't have to throw away everything you have built over the years. You simply need to learn how to layer AI on top of your existing expertise. And that's exactly what this next framework explains. A few years ago, AI entered our work lives primarily as an augmentation tool. We use it to improve productivity, review code, summarize documents, generate content, and help us with everyday tasks faster. But today, AI has become much more than that. We have now we are now building voice AI agent, multi-agent systems, intelligent workflows that can automate real business processes. That's where the next stage begins. We think about it as an AI upleving curve. The first two stages are about augmentation. First, learning how to work effectively with LLMs that we have been doing. Then using AI Copilot to multiply your everyday productivity. After that comes the transformation. That's where you start building AI agents, generative AI applications, enterprise AI systems, and eventually advanced machine learning solutions. Everyone starts from a different point, as Ryan mentioned. There's no one size that fits all the journey. The goal is simple, simply to build your own AI capability based on where you are today. And once you have decided where you want to be on that curve, the next question becomes, which role are these skills preparing you for? If you're looking at the hiring that is happening today, it's increasingly happening at the intersection of your existing domain expertise and AI. So if you're a engineer, the goal is to become AI-enabled software engineer. If you're a product manager, the than AI-enabled product manager. The same applies with engineering managers, technical program managers, data professionals, and many other technology roles. Today, AI skills are no longer just a nice to have. Across the industry, they are becoming an expected part of many technology roles. The idea isn't to replace that expertise you have spent years building, it's to strengthen it with AI, as I mentioned earlier. So if you are thinking, this is the year I want to start upskilling in AI in a structured way, not to just learn the skills, but also to prepare for interviews, then let me quickly walk you through the programs that we have built for exactly that purpose. We have designed two programs because professionals are at different stages of their AI journeys. See, if you're looking for a structured place to begin, I would recommend starting with our flagship transformative Gen AI and Agentic AI plus Interview Lab program. This is a 6 month journey plus 3 months focused on AI upskilling, followed by 3 months of interview preparation based on your background, your project, learning paths, and interview preparation, all are customized to your domain. Whether you are an engineer, product manager, engineering leader, or data professional, you will learn AI in a way that's relevant to that what you work or what you're already working for. The second program is Agentic AI Accelerator Interview Lab. This is designed for professionals who already have experience with Python, AI concepts, agentic AI, RAG, MCPs, AI workflows, and now want to build enterprise grade projects because many of you would want to do that. You will work on industry cases provided by PwC India, build production ready capstone projects across domains like BFSI, healthcare, e-commerce, and supply chain, and prepare for interviews while earning an industry recognized certification by PwC. Whichever path you choose, the goal is same to help you confidently build AI solution at the end and prepare for AI enabled opportunities out there. One thing that makes us different is that we do not believe in one fit approach at all. We have built 18 specific learning tracks because everyone comes from a different background. And I'm sure a lot of people here who are present right now are from different backgrounds and have different career goals. So whether you are a backend engineer, and I'm gonna name few and relate to what you are, front-end engineer, full stack developer, Android engineer, iOS engineer, test engineer, data scientist, machine learning engineer, cloud engineer, DevOps engineer, cyber security professional, embedded engineer, uh, engineering manager, product manager, technical product manager, you are in or you are early in your career. You just started. You are just like 2 years in your career. Your learning path is customized for your role. Simple as that. The bottom line is that you know which exactly you are, where you are coming from and what role you are going into. Your projects are relevant to your background. Your interview preparation is going to be relevant to your domain, specifically to your domain, and your career support is only designed around the kind of role that you are targeting, so it won't be same for all. The idea isn't to teach everyone the same AI. The idea is to help you apply AI in the work that you're already doing. Now once you have built those skills, the next step is to making sure that you are ready to crack interviews for these AI enabled role. Learning is one thing and going about cracking the interview is another. So let's talk about that. That's where our interview lab comes in. As you can see, along with learning AI, we also help you prepare for interview in a structured way. Depending on your domain, you will prepare for DSA, system design, AI focused interviews. As Nahid was mentioning, that what kind of questions can come and what kind of interview. And she was brainstorming on few and domain specific interview rounds. It can be any. So if you're an engineering manager or a product manager, your presentation is customized accordingly, specifically to your role. You will also get access to at least 15 mock interviews with experienced interviewers from leading technology companies. Ryan did mention that Anthropic, Google, Meta, along with detailed verbal and written feedback from those interviewers. Beyond technical preparation, we help you to optimize your resume. Of course, we have learned how to enable AI, we have learned how to crack interviews, but how about getting shortlisted? So we help you optimize your resume. We will help you improve your LinkedIn profile. We will help you with behavioral interview and even support you with your salary negotiation, because that is also a very important aspect. We also work with 200 plus hiring partners across India. So wherever applicable, Eligible learners receive placement assistance and referrals through our network, our networks of 27,000 plus alumni. The goal isn't to help you learn AI again. I keep on saying this. It is to help you become confident to interview for and succeed in the AI enabled role. Now that you have seen what learning journey looks like, let's quickly look at those program timelines. So if you're just getting started with AI or you're looking for a structured roadmap, transformative Gen AI and agentic AI plus interview lab is the place to begin. Over 6 months, you will build practical AI skills while preparing for interviews, helping you become an AI enabled professional in your own domain. If you're already comfortable with coding, have some exposure to AI concept, then the agentic AI accelerator plus interview lab is designed for you. This program focuses on building enterprise-grade AI projects, hands-on capstone, and industry-ready portfolio, followed by interview preparation and a certification by PwC. So whether you are just beginning your AI journey or you're looking to build advanced production-ready skills, there's a pathway designed for where you are today, according to your domain. Now, the next question most people ask is, what does the investment look like? That's the most interesting question. Here's a quick overview of both the programs. See, the transformative Gen AI and AI, agentic AI interview lab is priced between 1.5 and 2.8 lakhs, depending on your domain. You have to tell your domain to our PAs, program advisors, and they will be helping you with the pricing. The agentic AI accelerator plus interview lab, along with PwC certification, ranges between 2 to 2.8 lakh, which already has understanding of bit of AI and skills. To make learning more accessible, we offer flexible EMI options, scholarships for eligible learners, a 50% refund policy under applicable terms and conditions. If you're unsure which program fits for you, do not worry. Our program advisors will be happy to guide you based on your experience, background, career goals. Book a call with them. I'm going to share a link in the chat section. They will help you build a roadmap according to your domain. They will talk to them, understand, tell them about your career goals, map out your learning journey, where exactly you are in your learning journey, what exactly you would want to be, and they will help you map the right way. They will help you with the roadmap, and accordingly, you will be able to choose what is right for you. So I'm going to launch a quick poll right now. If you would like to talk to our program advisors to get in touch with you after today's session, or you simply like me to learn more about the programs, please let us know through the poll. I'll also share a book again. As mentioned, I will share a book a link chat in the book a link chat link in the chat, so you can excuse me schedule a conversation at the convenient time. And now let's get back to today's session. I am happy to introduce our next instructor for today. Earlier today, we learned how voice AI agents are designed and built for real world applications. Just give me a second. And now it's time for our final session, where we will be focusing on something that's just as important: evaluation and observability. Building an application is one thing, right? Running it reliably in production is something completely different. In this session, we will understand how to evaluate AI systems, monitor their performance, identify issue early, continuously improve once they are deployed. This is one of the most important skills for anyone building production ready AI systems. And with that, let's move to our final session of AI Launchpad. I'm excited to introduce our final speaker for today, Primanku Chakraborty. Primanku is a principal product manager at Atlassian, where he leads AI powered IT service management experiences for Jira Service Management, building agentic systems that autonomously resolve employee requests. He brings over 13 years of experience in enterprise SaaS and product leadership and has previously worked at Salesforce, Compass, and Deloitte. His expertise spans enterprise AI, AI-powered SaaS platforms, multi-sided marketplaces, and building products from zero to scale. I'm sure we are going to learn a lot from this session. So without taking any more time, over to Priyango. Hey, Priyango.
Thank you so much. Hope you can hear me okay.
Yes, we are able to hear you. Just let me stop my screen once and handing it over to you. All right.
All right, let me present my screen. All right, cool. Can you see my screen? All good?
Yes, I'm able to see your screen now.
Perfect. Amazing. First of all, thanks a lot. Definitely appreciate everyone who's taken the time on a Sunday to come and listen to us. So really appreciate that. We will, today in this session, talk about evaluation and observability. And I know we have about an hour and a half roughly between us, and then maybe like some time for questions. I also know that it's Sunday, so I'll try and make sure that I keep it as succinct as possible. But my goal here is to make sure that once you walk out of this portion of the session, you're able to very cleanly understand what is evaluation and observability when it comes to agents, right? Now, we've all heard about agents, we've all heard about LLMs, we've heard about RAG. We have also heard about evals, but I would say that, arguably it's probably less popular when it comes to, the limelight that it receives as compared to agentic AI, multi-agent systems, MCPs and all that kind of stuff, right? But it is also the most important thing that differentiates between building something which is just a demo versus something that actually works in a production-like environment, right? And that is what we will discuss about, right? So broadly, this is broken down into a few different parts where roughly about 40 to 45 minutes is what I'll cover in terms of certain concepts. I will then take about 20-25 minutes to do a quick demo, and then we'll open up for some questions, right? Now, hopefully you guys can put things on the chat, but tell me, can someone tell me when it comes to quality of a software, and we have all, worked in traditional software systems, AI softwares or agentic softwares are hard to get right in terms of quality. Can somebody tell on the chat why? Why is it hard to get the right quality on agentic systems? Can I see some responses on the chat? Non-deterministic, right? Perfect. So this is the biggest reason why between traditional rule-based systems, there's a difference between them and the LLM-based systems, right? Because like Omkar said, you could have two users give the same outputs and change no conditions, but get a completely different output from that, right? So that is the beauty of non-deterministic systems, because it can plan on the fly, it can give you responses on the fly, it can think and provide you a response. But at the same time, that also means that there is no easy way for somebody to look at the quality of the agent, right? So let's say, for example, I was building a calculation system using an LLM, and I put in an input of 2 plus 2 and it gives me the answer 4, right? I cannot trust that this system is going to always provide the same response every time I'm going to insert a 2 plus 2, right? Because it is non-deterministic in nature, right? And that is where the discipline of evals comes in. Evals is not a new concept. It has always existed in the AI, evaluation space, but it has become a lot more relevant now, because now building AI software is not restricted to a small part of your organizations. In a few years, we'll have almost 70-80% of the organization building some form of software which is AI related, and quality of that is going to become super important, right? It is still super important, but as the number of products in this space increase, it is going to become even more important, right? Now, do you guys know what is the number one reason for customers to not adopt AI? Any ideas? Thoughts? Cost. Cost is definitely one aspect, and it will become more and more relevant later. Security is another key aspect. Actually, I would say like among the top issues, security might be one of the top ones. But the other one is the trust, right? And when I say trust, it's trust not in terms of security, but trust in terms of making sure that the product provides the right responses. Okay. So thanks for those responses, Pravi, Namrata, Varsha. Thank you. Right. So let's now try and understand what is the reliability problem, right? So for our conversation today, we will take the assumption of let's say this hypothetical company, which is Meridian Software, right? Now Meridian Software is essentially building an agent which is called as Ask Meridian. Okay. Think of this as an agent that answers questions related to HR and product policies from multiple internal documentations that it has, right? Like the employee handbook, the product guide, some reference data, etc. Right? Now a user can come in and say that how many PTOs do I have after I've completed 5 years in the organization? And let's say there is a policy within the organization that once you've completed 5 years, you can actually ask for more PTO, right? So I'll also show you the agent a little bit so that it, visualizing it is easier to understand, right? So this is, let's say this is the agent. I'm just going to refresh this. And I can basically come here and ask that, hey, what is the, hey, how many PTOs do I get after completing 5 years in Meridian? Let's see what it does. It says that you're entitled for 28 days of annual leave, right? So behind the scenes, this is an N8N agent, and I'll walk through that when we get to the demo. But just for our understanding as we go, let's imagine this is the agent which has the policy documents, right? So it's an agent which is grounded in the knowledge. And then an employee can come in and it can ask for questions, right? Now, an agent like this is very helpful within the organizations because you do not want somebody to remember some of these things or go and ask HR people every time they have any kind of policy related questions, right? So that is where agents like this become very helpful. And this is something that I think most organizations today already have. Now, what happens is when you build this agent, of course, on the demo day, it works really, really well, right? So you ask it, how many PTOs you have, it gives you the right answer from the handbook. But then suddenly, a few weeks into the demo being productionalized, somebody goes and asks that, does this product integrate, does Meridian software integrate with Salesforce? And maybe it doesn't have that knowledge behind the scenes. Sometimes what it does is it will hallucinate and it will provide a response that may be super inaccurate, right? And based on that, that particular individual might take a decision, may communicate something to their customers or clients, right? And one of the bad and good things about the LLMs is whenever they'll give you a response, they will act super confident, right? So they will still be wrong, but sound very, very promising in terms of their response, right? So that is the damage that hallucination can do for AI agents. And these damages can happen due to multiple things, right? These hallucinations can happen due to multiple things. These are certain examples, but it could happen because the prompt for the agent has changed. the model might have changed, the documents might have gone out of date, or maybe there is too many documents, so it is unable to grab the context and it is hallucinating, or there are old documents as well as new documents, and there's no way for the agent to understand what is right or wrong, right? But the net result for the end user is that the agent has provided a wrong answer, which is not great, right? And what essentially happens is, this is an example of an internal use case where things could go wrong, but imagine sharing something like this with external customers. The trust of the product goes down and the product stops selling, right? You can't trust, and that is where the whole concept of evaluations and observability comes in, right? And like it's mentioned here, you cannot trust what you can't see or measure. And that is where the two important concepts come into play. One is observability. Observability is not a new concept, right? Observability essentially is seeing what's going to happen. And evaluation is basically judging what you have observed to figure out whether it is right or wrong, right? So what essentially happens is both of this in combination allows you to test the quality of the agent, right? So I'll very quickly talk about what observability is. Think of it again, like all of those who have been in the software industry are already probably aware of observability. We have multiple tools which looks at the traces of our softwares, the logs, etc., to figure out whether the software is working accurately or not. Observability in an AI environment is also the same thing. Think of it as a flight recorder, where if anything goes wrong, you can replay exactly what went wrong in order to figure out whether the agent worked appropriately or not, right? And that interaction, which is recorded and which is played back, is called as a trace, right? So let's take an example. Let's imagine we are all working on, I'm going to do some drawing here as we speak, right? So let's imagine we are using ChatGPT. ChatGPT, for all of us, is also an agent. It is also an LLM provider, but it is also an agent. Generally, you will provide an input to ChatGPT. Let's say that input is, who's the Prime Minister of India? And the output that comes out is Narendra Modi, right? So there is an input, there is an output, and then, ChatGPT obviously has an LLM behind the scenes that's working. It has certain tools which can do some web browsing, look at its knowledge and all that kind of stuff, and gives out the output. The combination broadly, again, not getting into the nitty-gritty details, but the combination of the input that got in, which is who's the Prime Minister of India, and the output that comes, Narendra Modi, is a trace, right? And you want to look at what happened in this particular trace to identify whether the session worked appropriately or not. I'll also show you some traces on a tool in a little bit, but just wanted to share that across, right? Now, for every trace, there are multiple things that you can track. You can track what was the question that was asked. If the agent went through certain routings, etc., to the right sub-agent, or it took a different path, you can look at that. If you're using a RAG-based agent, which in this case we'll look at the example of, you can also figure out if the RAG agent extracted the right chunks, and you can also see what response was provided, right? So you can evaluate across a particular agent where there is a question that is asked. Internally, there are certain decisions which is taken in a multi-agent system, and if the routing is correct or not. If you're using a RAG-based agent, did the RAG-based agent pull the right chunks or not? And was the response provided right or not, right? So you can test all of this. Okay, so let me spend maybe another minute on that. So let's say, for example, you have an input. That input or the query goes to an agent, and that agent creates an output, right? Now this agent can internally be a bigger system which has multiple agents inside this, and it could take decisions on where it goes. If it is linked with any kind of knowledge, then it will also use something called as a RAG pipeline, or retrieval augmented generation. We'll touch upon that very, very briefly as we go through this. In order to use a vector database to pull information, right? RAG is generally used in cases where we want to make sure that the accuracy of the information is high, right? Specifically in this example where we looked at Meridian, you would not want Meridian to answer what is the company's leave policy after 5 years looking at the internet, because it won't have the right information on the internet, right? It has to rely on some form of a knowledge which is created within the organization. And that is where RAG comes in, and that is where you link knowledge, right? So you can test all of that with traces, right? Also, every trace will also tell you how many tokens have been consumed, right? How many input tokens have been consumed, how many output tokens have been shared. What is the latency? That is, how much time did it take between the question and the response, right? Now, one of the things within LLMs is that they are slightly more latent systems than the traditional softwares, right? Because of the way they operate, or they are architected behind the scenes. And one of the things that is focused during evaluations also is that how can you bring down the latency? Because you don't want customers, especially for short tasks, to be waiting for long times for the response to come back. Because if that happens, you will essentially lose that customer, right? And they will, basically go to another product which can act quickly, or they'll stop using that product because it takes so much time, right? So imagine if you're searching something and it takes you like 5 minutes for the search results to come back. You'll not use that kind of search, right? And the third one, which is very important and is becoming a huge point of discussion in today's world, is the cost. So all of these is what you can see inside of a trace, right? So I'm going to show you a quick trace here. And we will again look at this in a little bit more detail, but just to give you a glimpse, the tool that I'm showing you here is called as Langfuse. This is an open source observability and evaluations tool. And I'm going to open a trace of something that I had run a while back. And you can see here that it shares what is the latency of the response that was received, what is the total cost spent on the LLM. It's very, very minuscule, right? It is much, much less than even 1 cent in terms of its execution. And it also talks about how many tokens were inputted and how many tokens were outputted, right? So it also gives you usage based on that. But besides that, it also tells you, what was the question asked, what was the output, whether it was correct or not, etc. So that is what trace is, right? So what you've seen here is the anatomy, like I was saying, a flight recorder system, which tells you the steps, right? So for this knowledge agent that we have built as an example, if you say how much PTO do you have left after 5 years, it is going to make sure that it is able to look at the knowledge, retrieve the context, and then give you back the answer, right? Cool. So that's a little bit about the observability part. Now, once you have the trace, what can you really do with it, right? And this is the most important part, or I would say one of the two most important parts of making your system accurate, which is evaluations, right? Now, let me ask this group, what do you think are the ways to evaluate an AI-based system? How how do you ensure that your AI-based system is high quality? What kind of tests can you run? Can somebody put something, their ideas on the chat? Deployment, okay. Anything else? See, try to think about your traditional world, right? In your traditional software world, you would write some test cases, you would execute them, you would see a pass percentage, and you will say that my software is high quality. How do you do that in an LLM system? So Varsha has a good answer. You could do a grading round by SMEs, right? You can actually take the output to some of the SMEs and ask them to give some inputs and look at the outputs and tell us whether that is accurate or not. That is great. That is one way. Somebody said automation testing, but I think there's more depth that is required there. Same input is equal to same output is what Omkar is saying. Omkar, to some degree, yes, but LLMs by their nature do not give you the same output. But I think if the spirit of your question is that, if I give 2 + 2, it should ideally give me back 4, then yes, but that's a single test case, right? Shreya has mentioned LLM as a judge, which is great, right? So this is one of the mechanisms, by the way, that we use in order to evaluate our systems, right? Now, one thing that I want for us to keep in mind is that LLM quality is a continuous thing, right? It doesn't stop with one round of testing. Generally, for all the people who build products for the first time, they would do what is called as vibe evaluations, right? They'll write a few questions, look at the responses, and then say that, oh, yeah, looks like my LLM is working fine, right? Or maybe like create 50 test cases of requests and responses, test them out and say that, yeah, for all of these 50 requests, it looks like my LLM or my agent is providing the right responses. So it looks like it is good, right? But that is not how evaluations are done, right? There's a whole discipline behind this area where there are ways in which you run your evaluation across your agent across different dimensions, right? So let's dive into that. So here you're seeing 2 examples of the types of evaluations that you can create, which is groundedness and helpfulness. Now, these are terms that you will hear when you think about evaluations. So I'll keep flipping back and forth on the slides, right? There are essentially 3 types of evaluations that are predominant in an LLM world. Okay, so we will talk about that. Let's come here. So the first type is called as self-evaluations. The second type is called as LLM as a judge. And the third type is called as human evaluations. Okay. Now let's understand this. If you were in your interviews and if you're not able to explain what are these different types of evaluations, then people will know that you haven't built the right agentic systems or know about these agentic systems, right? So what are self-evaluations, LLM as a judge, and human evaluations, right? So let's talk about that. Let's maybe start with the simplest one, which is easy to understand, which is human evaluations. Can anybody put on the chat and tell me what are human evaluations? Very easy to understand from the nomenclature. What are human evaluations? Manual review by a human. Perfect, right? So this is something that somebody had already mentioned earlier, which is you could take it to an SMEs, or if you are the SME, like a product SME, or you're the customer who understands the business, you could actually create a set of queries and look at the responses back from the LLM and evaluate and say that, hey, of the 200 queries that I run, 180 of them were accurate, right? That is what is human evaluations, right? The second one is, so the benefit of something like this is that this is the most accurate or the strongest form of evaluation because there's a human that is evaluating this output, right? But in a production system, you cannot do it at scale, right? Because you have probably millions and billions of conversations. Like take the example of ChatGPT, right? There's billions of chats that are happening every day. And ChatGPT needs to ensure that it is able to constantly evaluate the quality of its output. It's able to trace it, right? Like every flight taking off, every chat is a flight taking off on LLM. It should be able to review it and make sure that the output quality stays high, right? So that is where there are two other types of evaluations that comes in, which is self-evaluations and LLM as a judge, right? So what is self-evaluation? Let's talk about that. Okay. So for example, let's say, you go to ChatGPT. I'm going to simulate a little bit of this in ChatGPT, right? So let's say you ask ChatGPT that, hey, can you tell me if can you tell me what's the best mechanism to become the prime minister of the world if imagining it were possible? Help me with a path for it. Also, at the same time, please evaluate this against hallucination, accuracy, and bias. And give me a table at the end with a score and explanation of score. Okay. So by the way, what I'm trying to do here is, here I'm already doing a very mini version of evaluation, right? Where I'm trying to basically ask this ChatGPT to self-evaluate the response that it is going to provide. Okay, so let's copy this and let's open ChatGPT. All right, so let me paste this here and let's see what happens. All right, so it does come up with a thought experiment, make some assumptions, right? It creates some, phases. It'll take 10 to 20 years. You have to build international influence, solve global problems, earn broad trust, blah, 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 right? Campaign, etc. Skills that would matter, major obstacles. Now it also scores itself, right? In terms of the three dimensions that I had spoken about: hallucination, accuracy, and bias, right? And it also tells that the response explicitly states no such office exists and frames the rest as a hypothetical situation. That means it is not hallucinating. So it gives itself a 5 out of 5 low risk score. Accuracy also, it gives a 5 out of 5. That there is no world government or prime minister of the world. So this is fine. And then it also gives bias as 4.5. Now here it has scored it slightly lesser than perfect. It says the response avoids favoring any country or ideology. One mild limitation is that it assumes a democratic and cooperative model for global governance, whereas the hypothetical governance structure could exist in fiction or alternate, right? So it does tell you the responses as well, right? Now this is called as self-evaluations, where the user or the LLM system that is creating the response itself is evaluating itself as well, right? Now, generally, such type of evaluations are the cheapest form of evaluations that can happen in terms of cost, because you can do these evaluations in the same prompt in which you have asked the question, and you can do this at scale for all the queries that are happening, right? So you put a system prompt that every time there's a query that runs on ChatGPT, as soon as the query ends, evaluate it against some of these parameters. You can do so, and that is called a self-evaluation. But the challenge with a system like this is, it's almost like a 10th grader who is taking their board exams also evaluating their own results, right? Which is, there's a lot of bias that is introduced because you are evaluating the response in the same context window in which you have asked the question as well, right? So that bias gets introduced. And that is where the concept of LLM as a judge, which is at scale the most powerful thing that you can do, where you have a separate judge agent and ideally running on a different LLM than the one that you use for your agent, which does an evaluation for you, right? So that is what LLM as a judge is, right? So human evaluations, just like going across the spectrum, self-evaluations is the most scalable evaluation, lowest latency, but also the least perfect in terms of the accuracy. LLM as a judge, slightly more expensive because you do run LLM as a judge on every response separately, which means that every time there is a run, you also have a separate run cost for the LLM as a judge. But in terms of accuracy, it is much higher than self-evaluations because there's a separate judge, separate LLM that is evaluating the responses. This is also something that you can do at scale, but cost becomes a factor. So typically, in production systems, you might be running it, like if you have millions and billions of interactions every day, you might be running it on 1 or 2%. If it is 100,000s or to that scale, maybe you're running it on 5%, right? It depends on how much volume you have. And then you have human evaluations, which is the most accurate form of evaluations, but also the most expensive form, right? So you can't run that at scale, right? So these are the different choices that you have. Now, how does AI grade another AI, right? So the judge is essentially given a few things, right? So how do you make sure that, now that I've asked this question, I can understand whether the response is accurate or not, right? So once the question and the answer has been completed, right? Like in this case, how many PTOs do I get after completing 5 years? The response comes back as this. What the LLM as a judge does is it takes both of these responses, right? So it collects the strays and it gives it to the judge. What the judge does is now it evaluates the question and the response based on the different scores that it has, right? Now, these are not the only things that you can configure, right? So if I go to, I'll maybe show you what an LLM as a judge also is, right? So if I go to evaluators, and so you can see, right? Like these are a bunch of evaluators that already comes outside of the box within LangFuse. Today for our demo purposes, we'll not be using any of these. We have built our own evaluation judge, which we will be using in order to test these two things, groundedness and helpfulness. Groundedness means how grounded is the response based on the knowledge that it has behind the scenes, and helpfulness is how helpful is the response, right? However, there are all of these different types of out of the box LLM judges that already come with LangFuse, and there are new ones that you can also create, right? So we'll take an example of hallucination. And you can see here that each of these LLM judges will have a prompt, right? So here the prompt says that evaluate the degree of hallucination on a continuous scale of 0 to 1. A can be considered to hallucinate. Score of 1 means it is hallucinated. If it does not align with the established knowledge, verifiable data, or logical inference, and often includes elements that are implausible, misleading, or entirely fictional, right? So this is the instruction that has been given to the LLM judge, right? The input that it takes is the query and the response that was generated. There is also an example or a one-shot example that is provided where the query is, can eating carrots improve the vision? And the generation is, yes, eating carrots can significantly improve your vision, especially at the night. That is why blah, blah, blah. So clearly this is wrong, right? So the score that is given is also 1, which is completely hallucinated. And the reasoning that is provided is carrots only improve vision under specific circumstances, right? Not every time. So similarly, so I gave you an example of a dimension using which you can measure the effectiveness of the judge, right? Which is 1 is hallucination, similarly of groundedness, helpfulness, etc., etc. Right. Now, how do we score these? Again, you can determine your scoring scale, but for our example today, we will score something as 1 if the claim is supported by by either a proper document with a response, or if it does not know the answer, it should basically say that I don't know the answer, right? So for example, if I go to Ask Meridian and say that, do you know the leave policy for, let's say, Microsoft, once an employee has completed 5 years. Now, this for a fact I know is not in the documents that I've uploaded in this particular agent. So ideally, it should not give me a response and say that, hey, yeah. So basically, it says, I'm glad you're reaching out. However, I can only assist with questions related to Meridian HR policies. If you have questions about those, feel free to ask, right? So it does not give a response, which is great, right? Which means it is still grounded. It does not give you the answer, but it also doesn't hallucinate, right? And try to generate an answer, right? And helpfulness is answers that are clear and complete or point to them. And we have said that in this judge, anything that is vague, partial, or off topic is not accurate, right? And then we look at the confidence score on both to determine whether it is accurate or not, right? So an example is, does Meridian CRM integrate with Salesforce? And we have no information about this in our knowledge system. And the response comes back that yes, Meridian CRM integrates with Salesforce. That clearly means that this is not the right response. And this is what your judge LLM should be able to pick up and say that, these responses are wrong. And if this happens frequently, let's say for every 100 interactions, your LLM is less than 50% grounded and less than 50% helpful, that means that kind of an agent is not high quality. And that is what you measure with LLM as a judge at scale to make sure that the quality of your output is high, right? So quickly bringing both of these concepts together, you do an evaluation, you get a bad score based on the observability trace, and you identify the fault, right? So bad score isn't just a number because evaluation also has the ability to explain why it says what is wrong, right? Cool. So let me skip through some of them. And now I'll probably go to the demo at this point and showcase how this is going to work, because that is where the most of the fun is, right? So essentially, the tooling that we are using here is we're using n8n in order to build the Ask Meridian agent that I will show you in a little bit. We also are using NA10 in order to consume knowledge from company documentation so that we can ground the data. We are also using NA10 in order to build the LLM as a judge agent, right? So I don't know if NA10 was covered as part of the previous classes, but NA10 is a very popular, automation and agent building platform where you can build workflows in order to do any kind of agentic work or even non-agentic work, right? We'll show that to you in a little bit. And then we are using LangFuse, which is an open source observability and evaluation platform on which we will look at the traces. And I'll also show you some of the eval outputs in NA10. Okay. So let me show you the setup first. So we'll be, kind of toggling across these three things. I'll start first with NA10, right? So there are three agents that we have in NA10. The first agent, let's open that real quick, is the ingest knowledge agent. Very briefly, what this ingest knowledge agent is doing is that it will read certain knowledge articles, which are stored here in my local system. So there's about 10 different articles that are present there, which contains the HR related information. It contains the CRM related information for the organization, etc., etc. Now, this is a slightly complex part, so not going to delve into the details of it. But what happens is, generally, when you're using knowledge sources, you would store that information as something called as okay, this was covered in brief already. Perfect, right? So you will essentially store that in a vector database through something called as embeddings. And then you will convert the embeddings into vectors so that you can do easy data storage, right? So this is the first part of the agent where you are ingesting the knowledge. The second part is this ask meridian agent, right? So simply put, when a question is being asked, it will basically try to determine if this is something that should be answered based on the knowledge base, or is it something which is general. And if it is something that should be using the knowledge base, it will take this route and it will go through this route, right? So I'll just zoom in a little bit. So essentially, the orchestrator will basically route this. Yeah. So the orchestrator will basically either route this if it knows that this should be answered based on the knowledge it has to this part, where again, the knowledge will be retrieved from the vector database from the previous one where we stored the data, and then it will give back a response. And if it doesn't, if it knows that it should not be looking at the knowledge because maybe the question is something pretty random, like this one, for example, it shouldn't ideally go inside the meridian knowledge, right? If I'm asking for Microsoft's data, then it should take a general route and then try to build out a response, right? So this is what it essentially means. And this is the agent that we've exposed also through this HTML, right? So behind the scenes, the agent that is working is this ask meridian agent, right? So every time we run something, it basically stores it in these executions, right? So you can see that 1426, when I ran this the last time, let's see what it did. It basically, recorded this execution and asked that, and basically put this question that, do you know the leave policy for Microsoft? Gives a response. And captures a bunch of other things, right? So yeah, so that is your ask meridian agent. And the last one in the in NA10 is this LLM grader agent or Meridian grader agent, which is the LLM as a judge agent. Okay. Now, how does this work? This essentially says that, give me the query and the response along with the trace, and I will do an evaluation on top of it. And it will ultimately post the results. Okay, so I'm going to show an old execution, and then we will also do something together. Okay, so this is an old execution that I ran at around 137 when I was testing the system. If I go to the summary here, this is the question that I asked. How many days of paid time off do I get after 5 years at Meridian? And the answer that it provided was, after 5 years at Meridian, you are entitled to 28 days. And the judge basically said that the groundedness and helpfulness of this answer is 1 and 1, which is high, right? The scale is 0 to 1, and it gives the answer as 1. And it also provides a reasoning that the answer accurately reflects the leave entitlement for 5 years as stated in the context, right? So because this response is good, this is how it's been recorded and provided, right? So every time I actually run this, it'll give me back that response. Okay. Now, one of the challenges that I'm facing actually is we are not able to connect. When I was testing this a while back, I'm not able to connect the interactions here. So when I do the demo, I'll pass the question through PowerShell into this particular agent, and then we will look at the response, right? But essentially, these are the 3 main agents. So I just wanted to quickly first explain these agents, right? So first one ingests the information. The Ask Meridian agent uses that information in order to provide a response wherever the question is in context with the knowledge that is present there. And this agent, which is grader or LLM as a judge, essentially executes the judgment criteria behind the scenes to tell us whether the agent worked fine or not across the 2 dimensions of groundedness and helpfulness. Okay. Now, I'm going to stop sharing and I'm going to bring my full desktop on for a little bit because I'm going to flip between PowerShell and this one. Okay. So now let's do this. Let me see what I want to show you first. Let me first pick up a trace and show you certain things. So LangFuse behind the scenes is connected to environment variables across the NA10 instance that I'm using. So if you can see, the NA10 is running on my localhost port 5678. And behind the scenes, I've connected this localhost port to LangFuse. And as a result, every time I do an interaction, it generally takes a little bit of time for the traces to show up on LangFuse. But when it comes, it essentially shows me the latency, the cost, the number of tokens used, the input, output, etc. Right? So this is how usually this particular system is connected. And again, you can also use LangFuse in order to build your evaluators or LLM judges. Like I was telling you, you can basically create evaluators here. So that every time, for example, if I choose hallucinations and I just hit execute, every time I run something over here, for example, what's the capital of Mona Gonda? Just going to take a hypothetical, country name. It says it cannot respond. At the same time, what happens is these pre-built out-of-the-box judges that come with LangFuse will also start evaluating. Looks like it hasn't yet, so maybe the trace is taking some time, but we'll come back to it later on if we have time left. But now let me show you. Let me open PowerShell. And because I said, there's some challenges I'm facing with running this grader as a judge directly, I will send a query through this LLM. Okay, so I'm just going to copy a command. To insert this. So basically, this is the question body that I'm sending, which is how many days of paid timeout do I get after 5 years at Meridian? I'm going to change that a bit and say, what is the per diem allowance for an employee that is visiting to London, let's say, for example, and I'll hit enter. All right. So now it would have executed behind the scenes. So I'll just go to executions. And you can see that this is the execution, right, which happened close to 241. So let's open this execution now, and we'll look at the logs. Yeah. So we can see here that the average groundedness has come as 1, and the average helpfulness has come as 1. The question that was asked is, what is the per diem allowance for an employee that is visiting to London? The response is the per diem allowance for an employee visiting to London is $65 for meals per day and $220 for hotel accommodation per night. And the reasoning that it gives us, the answer accurately reflects the per diem allowance for London stated in the context, right? Now, this is, I can tell you this is accurate because this is present in our document, and hence it comes back with this response, right? And now, so basically this is your LLM as a judge, and it is evaluating against 2 criteria, but based on your problem statement and use case, you can also have other criteria, right? And at the same time, let's see if I have the trace for this. Yes. So I'm just going to copy this and go to traces and paste this. It might take a while for the trace to appear here, but let's see if it does. Yeah, it's going to take a while. So I'll just copy this trace, keep it on the side, and we'll come back. If I go to the evaluators. Okay, this is also not captured, which is fine, right? But essentially, Uber point being that this is how you can run your evaluations. Okay. And you can do this at scale. You can do this for every conversation that is happening on your LLM. And with that, you will be able to test whether your system is working fine or not. So generally, like just to give you a little bit of sense, in order for you to test this, right, you don't need to be actually working on a product in order for you to learn something like this, right, or gain your expertise in this. Because, one of the questions that I often get with people who are trying to learn agentic systems is that, hey, I'm not working on an agentic product or an LLM product. That is fine, right? In today's world, you have all of these products which are available for free or at a very low cost for you to come test and become an expert, right? So what we were doing here, for example, is we were running N8N locally, which is completely free. We were using the free tier of LangFuse in order to see the traces, which is also free. The only thing that I've used here in both all my agents, wherever there is a LLM step for extraction and things, is the OpenAI API, which costs very few cents for multiple LLM judgments, right? So essentially, the reason why I wanted to state this is whether you're doing this for your own personal learning, or if you're doing this in order to do this within your organization, this comes almost as at a very low cost for you to get started, right? So essentially, this is what happened. We ingested the data. We ran the Ask Meridian agent. It goes to the knowledge RAG if the agent is relevant. The question is relevant to knowledge agents. Otherwise, it goes to the general agent. Then it goes to Langfuse for traces and scores. And then it also goes to the grader agent in order to judge every score, right? So this is what we have done so far, right? So we walked through the workflow. We asked some live questions. We ran the grader, and this is something that we'll try and do. But before that, let me try and put another question here. Let's say the question that I ask is, how do I increase my per diem for London visit from what's directly offered per company policy? Now, I'm sure this information we do not have in our system, so we'll see how it reacts. Ideally, shouldn't take this much time. Let's see. Yeah, I'm not seeing this executing, so I'm just going to copy paste this and open another PowerShell. Okay, it's probably because of the syntax, because when I did what's with the apostrophe, it basically concluded the string there. So even here it has come up with groundedness and helpfulness is 1. If I go back and refresh the executions, I will now see this one popping up at 247. And again, let's go to the summary. It states that how do I increase my per diem for London visit? The response it provides it to increase your per diem for London visit beyond the blah, blah, blah. You will need to obtain written pre-approval from your manager. Please contact the people team. Okay, the answer accurately reflects the need for pre-approval. Okay, so there's maybe something in the documentation that states that, and it gives back the response, right? So this is how the LLM judge works, right? Now, one thing that I will state is the response that comes out of this Ask Meridian is based on the prompt that is mentioned here, right? So if I just expand the prompt, this is the system prompt, right? Or the main prompt that is working, which says that you are Ask Meridian, the internal help desk assistant for Meridian software. Answer. So it's basically instructions that are provided. And it says keep the answer factual and all of those things. Now I also have a slightly bad form of the prompt. So what I'm going to do is I will copy that bad prompt and paste it here. Yeah, okay. And I'm going to close it and publish. And let's just go back and check that the prompt has changed. Confident and enthusiastic. Yeah, okay, perfect. So now let's run this again. And maybe the scores will change, maybe it will not, we'll see. But I'm going to run the same thing that I'd run again and see what comes back. Okay, it still gives back the same thing, which is fine. But sometimes the reason why I was trying to show that is sometimes when you change your prompts, the quality of your output changes as well due to regressions, right? It didn't happen in this case, but sometimes that does happen. Okay, so if I go back again to the grader agent, and I look at the executions, this is the latest one that it ran. Oh, no, looks like a old execution. Let me see how many days of time off do I get. Okay. Okay. Yeah, it basically ran the same thing, but it didn't deplete the quality of the response, which is why it gave this response, right? So that essentially kind of wraps up what I wanted to cover. Bottom line that I wanted to state with this thing is, whenever you're working on any kind of LLM softwares or agents, you need to have this framework in order to make sure that you're able to judge your product at scale, right? So you need to make sure that you see your traces for every run, you're storing them, you're measuring the answer quality based on scores for groundedness, helpfulness. You are able to, if you see that the quality of your scores are going down, then you should essentially figure out what can you do in order to improve them. Should you change your prompt? Should you change your knowledge? Should you use a different model? Maybe you should use a multi-agent system instead of a single agent system, because that is causing some problems. So you need to go and then figure out, based on the responses that you've provided, as well as the explanation of those responses, in terms of what you need to do, right? So it's a pretty big concept. We have only touched the brief background of it. But with that, I'll take a pause here, and I'm happy to answer questions, if any.
Guys, you can ask questions in Q&A session. Thank you so much, Priyanka, for such a wonderful session.
Thank you. So one thing that I would mention is, if you are in a, of course, if you're in an engineering role, this is super duper important. But if you are in a PM role or a TPM role, and if you're going for an interview, this is the one part that you will be asked quite heavily on, as to how would you make, because those are the roles which essentially need to ensure the quality of the outputs that are created. And so you will be asked heavily on how do you ensure that you maintain the quality, right? And you should be an expert in evals in order to do so. All right. I can see that there are some questions coming in. Are we able to integrate all these? Yes, you can do this on innate and trial versions. What I've used is actually a desktop implementation of it, but you can also do that on in trial versions. All right, if there's no other questions, I'll maybe hand it over to IK.
Thanks, Priyanku. Thank you. Thank you so much for a great session again. That was really insightful session. I hope all of you enjoyed it. There are some comments coming for Abhinav as well. Thank you so much, Abhinav, for being there, answering all the questions when Primangu was taking the session. And with that, we have come to the end of AI Launchpad. Over the last 2 days, we have covered a lot, from RAG and multi-agent systems to voice AI agents, and finally, evaluation and observability. I hope these sessions have given you a good understanding of what's happening in the AI space, and more importantly, where you can start your own journey, most importantly. If you would like to explore these programs further or understand which learning path makes the most sense for your background, feel free to book a call with one of our program advisors using the link we have shared in the chat. They will be happy to answer your questions and help you figure out the right next step. Also, if you would like to revisit this particular session, or share with someone, the recordings are available on Interview Kickstart India YouTube channel. So do subscribe if you have not already. Thank you so much for spending your time with us over the last 2 days. We really appreciate you being here, asking great questions, making the most of it, and making these sessions so engaging. Have a wonderful day. Keep learning, keep building, and we hope you to see you again.